Hello, my name is Danny Tran, and this is my video explainer for the midterm. I apologize, I don't have a camera, so you can't see me, but the best I can do is just record my screen. Anyways, so in this assignment, our goal is to analyze the bias/variance trade-off in order to perform model selection, and we will be using the code that we wrote in the first coding section. So it's pretty similar. We're just following the Jupyter notebook that we wrote before, and we're changing some of the data and functions. So our ground truth model this time is going to be f of x equal to x squared plus sine x. We'll have 10,000 training observations, the same interval with a different x max, so equal to 2 this time, and our standard deviation will be 0.5. We're going to have 100 test observations in a different interval so that we can pretty much predict where it's going to go. So you can see the instructions here, our imported libraries, all the code here. And then you see that the ground truth model is in green with the 10,000 blue training observations, and then the red points are our test observations. And you can see it pretty closely follows the curve here. Next, we want to learn which polynomial will best describe our function. And so we have degree polynomial 0 to 5 here, and we have 1,000 experiments, and we're picking 1% of the 10,000 training observations that we had up here. And this is all the code to train it and plot it. And so we can see here that we have, for each experiment, I only plotted 6 of them out of the 1,000, but we have each degree, and we see that they differ sometimes, and we have the variance as well, and pretty closely matches how we're doing over here. And then we get into the bulk of what we want to learn about. So we want to estimate the average squared training error, average squared test error, squared irreducible error, average bias squared, and the variance of the predictions in the test set. And we're doing that for each degree polynomial. And so this is basically the bulk because this is what we want to do. We want to analyze the bias/variance trade-off in order to perform model selection, and we do that by testing each degree polynomial and seeing which one gives us the lowest test error. Right, so we have our variance and the bias squared for each degree, and this is just the first step. We see that it's pretty rough for degree 1, getting closer for degree 2, not bad, getting closer for degree 1, not bad for degree 2. You see degree 3 is very close in bias, very low bias, but the variance is getting higher, and you can see that by the curve getting flatter. And by degree 5, the variance is very high, but you hear that the variance is like pretty much spot on. Or sorry, the bias is pretty much spot on. Next, this is where we actually find what the test error is and the training error, and we see which degree will give us the lowest error. So we have all the code here. We're training errors and then our test errors, and then we want the mean and standard deviation of both, and we're just plotting it. And so we see that for the test errors, the mean and standard deviation, they're going to be the dashed lines, and the solid lines are going to be the training. And then we have the red line for bias and blue dash for variance. Although it's a little hard to tell, the bias/variance trade-off does match. As you can see, the variance is going up right here. You can see the dash line is a little bit higher than down here, and the bias is going down like this, and it's below the blue dash line. So we see that the degree of the lowest mean test squared error is 3, and it does fit the bias/variance trade-off. And so that's what we wanted to learn using the code that we wrote in class. And so, yeah, that is all. Thank you.